protect your soul.
What up? How's it going, everybody? Thursday. I don't know about you, but this is the Friday-est Thursday that I've had in a long time. There's just something about today that has me convinced it's the end of the week. Oh, look. I was hoping it might help reduce the glare a little bit, which if I was any smarter, I would have put it on the other side of the glass, which maybe I'll do next time. But I put up my Omicron poster. I really should have put that on the other side of the glass. That would have been a lot smarter. Perfect intro. That's what you're going to get for the next couple hours. Really bad choices. Well-intentioned, poor choices. That's what I should have called this stream. Hey now. All right. Let's see what the old let's set it to pro, baby. Let's see what Senior Gemini wants to come up with today. Hold on, we gotta crack the old DC. Boom. Nil. What up, buddy? Thanks for coming in. How are ya? We are going to be doing some more Boot.Dev today, bud. Pretty excited. Oh, hey, that's not bad, Gemini. I like that one a little bit more than the other ones you've done. Day's good. Day's good. I was just saying, I feel like it's Friday. I don't know why, but all day I've been like, it's Friday. It's definitely Friday. Just get through the day, and then we're on to the weekend. But no, that is an incorrect assumption. How about you? Day's going good? Oh, I just opened up your thing. Look at that. How fun. Yeah, it's been good, though. Just, I'm excited to do some more Boot.Dev. We're on to selection sort, which is sweet. We've done bubble sort. We've done merge sort. We've done insertion sort. We did the one yesterday, which I currently forgot the name of. What did we do yesterday? Hey, what's up, Mr. Tucker? Quick sort. We did quick sort, of course. Of course, classic quick sort. Oh, should have done my hair a little bit better, eh? Yeah, we did some quick sort yesterday. We're moving. It's actually been a lot of fun. I've always wanted to do a algorithms course, and so this has been good. I have clearly been mastering it and remembering everything as I go. Well, yeah, today we're going to spend a couple hours on, hopefully, if all goes well. Oh, I only have one? Okay. So we're going to get done chapter 4, I think. I shouldn't be too eager. It wouldn't surprise me if I start this one and it just ruins me and ends up taking forever. But ideally, we'll get through selection sort, and then maybe we'll go into exponential time. Alavo, what's up, big dog? How you guys doing? Who's ready to watch some struggles? Every day we're struggling. That is just how we do. Okay, I like to give a few minutes for my legion of fans to come in because I'd hate for anyone to miss out on this high quality stuff. But we'll start in a few minutes. I think I got everything set up today. So you're struggling? Every day I'm struggling, Alavo. I don't even know what I'm doing half the time. But it's a good time. No, he's John. Oh, yeah. Oh, such a good dad joke opportunity, and I blew it. Oh, no. I might just have to cancel this stream. That's embarrassing. That was dad joke gold. and I absolutely blew it. Nil, thanks for coming in with the save, to be honest with you, man. Like, man, oh man. Hey, what's up, YouTube? Ta Ninja, how are ya? Ready to learn some data structures and algorithms? And some sweet dance moves that you can do while you're sitting in your chair? I'm swiping Tinder until I run out of swipes. I don't know what's the most effect tactic available here. I don't know, man. I found my wife just before Tinder started being popular, so I don't even know what Tinder is. I think I've gone on Tinder one time and just to see what it was all about, and I did it with my wife, just FYI. Like we just checked. I just wanted to see what it was, and it was just like, oh yeah, this looks like a nightmare. If I had to do this, I would probably just be single for the rest of my life. You ran out of time, now it's asking you to pay? Dude, I'm telling you, just bail. Go do other things. I don't know. I was never a big dater. I have horrible dating advice. I was never good at it. So my dating advice is don't worry about dating and just do things you enjoy and walk around the city a lot is what I used to do. That's actually, so if I really think about it, how I met my wife was I was walking around the city of Toronto and happened to come across a flyer for something called the Fringe Festival, which is like a festival where people put on plays and all that sort of stuff. And I was like, oh, this is cool. I was like, maybe I'll go volunteer at the Fringe Festival. That might be a good way to meet some new people. And so I went and volunteered, ended up meeting a crew of people that I started hanging out with. One of them was a producer of plays, and they had just rented out this space to do plays in. And he's like, hey, do you want to invest? And I was, at the time, I had no money. I think I literally had like $600 in my bank account when he asked me. And I was like, sure, how much? He's like, $500. And it was like, we'll get you your money back plus a cut of the profits from any ticket sales. I was like, sure. So I donated my $500 and then waited until payday to do anything else because I had no money. And then, you know, a couple weeks or months, I don't even remember how long it was, go by. Finally, they have the opening night of the play. I go to the opening night, and while I'm there, I'm standing around, and there's this one other girl there that I decided to go talk to. I opened with, like, you know, the smoothest thing ever. I had just recently been learning about ghost hearts, which I don't know if you know what ghost hearts are, but at the time that's what they were calling when they would like reproduce the shell of a heart out of stem cells. But it wasn't, so then you could like use it to regrow a heart basically. And so I opened with talking about ghost hearts, and she didn't leave. And that was, I found out a little bit later from her that most of the reason that she didn't leave was that her sister had given her a camera and she was supposed to be taking pictures, and she felt bad about, like, you know, not taking pictures and walking away. So effectively, I like kind of had her cornered accidentally. I didn't even realize it. She wasn't going anywhere, so I could say whatever I wanted, it turned out. And then we talked for a little bit. And then because I was super cool at the time, I thought it'd be like really cool to give a business card with my email and phone number, you know. And then I emailed her, asked her if she wanted to go out. She did not reply for a couple days, and I was like, oh, guess not. And then eventually she got back to me, and we had a couple email exchanges, and then went out on a date. And now we're married for 10 years and been together for 15. and have 2 kids. So I guess all I can say is don't worry about it. my dating advice is don't stress about it and just go live your life, man, and see what happens. Yeah, it's a pretty cool, it's a fun story. It's definitely an I enjoy the story. But yeah, I think like, okay, every girl I dated, I kind of met them in a weird way. Like that, one of the girls I dated before I met my wife, I met her, it was just after Christmas, and we were at the subway station, and then the subway broke down, and it was pouring rain, and so I was just like, do you want to share a cab? Because it turned out we were both going to the same place. And so we shared a cab, and then we ended up dating for a couple months. She was from Brazil, though, so she was only here for a little bit of time. Hold on, what'd you say, Alavo? At the club, I walk up to girls and ask, "Ayo, do you want to kiss?" It never worked. I mean, yeah, that's a pretty aggressive move. I don't know if I'd recommend that one. One of the girls I dated in university, she, I think I've had like 6 girlfriends, probably, like real, that I would actually get like girlfriends. And one of them in university, she used to deliver pizza to the hotel that I worked at for guests. And somehow I found out that she had a boyfriend. And I remember saying something along the lines of like, you know, if you ever smarten up and leave your boyfriend, you know where to find me, or something really cheesy and silly. And then, like, I don't know, a month later or something, she came back and was delivering pizza, and she was like, "Hey, guess what?" And she mentioned that she was no longer with her boyfriend, and so I asked her out, and that was it. Girlfriend, never heard of her. I mean, yeah, it's it's a life. I was not very cool, I'll say that much. Like, I had a few girlfriends. I've never been that cool. And as I've gotten older, I've started to learn a lot about myself and growing up and things that happened and why I'm not that cool. So I come by it honestly. What can I say? I come by my uncoolness very, very honestly. All right, what do you think? I've wasted a solid 15 minutes almost. Should we jump into selection sort? Let's get this thing going. I'm ready for it. I'm ready to learn. I think today should be a full day of like getting to go to 5 p.m. So that's like from now, it's a full hour and 45 minutes. If that changes, it could happen. Sometimes I get calls that the kids need something and then I just got to go. But you guys have the plan. You guys know the plan as much as I do. So, all right, selection sort. Let's get started. Another sorting algorithm we never covered in depth is called selection sort. It's similar to bubble sort. No plan B, no plan B ever. Alavo, ever. I barely get through plan A in my head. So, I'm at like, I get like plan half A. That's about as far as my planning goes. It's similar to bubble sort in that it works by repeatedly swapping items in a list. However, it's slightly more efficient than bubble sort because it only makes one swap per iteration. Okay, let's do some pseudocode. So for each index, set the smallest IDX to the current index of the outer loop. Then for each index from I plus 1 to the end of the list, if the number at the inner loop index is smaller than the number at smallest IDX, set smallest IDX to the inner loop index. Swap the number at the outer loop index with the number at smallest IDX. Return the sorted list. Whew. Hey, Nadia, what's up from YouTube? I have a question, Nadia. If you're there, are you watching on vertical or desktop? I looked at the stats the other day, and it seems like almost nobody watches me on like desktop on YouTube. It's all the vertical one, which Twitch has the vertical one, and I thought I learned how to do it, and I did not. So I need to remember how to figure it out because they just added it recently. Assignment. Complete the selection sort function. It should sort the input list nums in ascending order. Hola, Maria. How are ya? Thanks for coming in. We're doing some selection sort. The function should then return the sorted list. Okay, so let's go through that pseudocode and try and do it. And we'll see what happens. So first we start off with a for each index. So for... Oh, wait, what does nums actually print? Hold on one sec. I just want to see what nums comes in as. Oh, okay, perfect. That's what it comes in as. Great. So for I in nums, we're gonna do smallest IDX equals the current index I. Hey Addison, what's going on? Welcome. We're doing some selection sort. We're trying to see if we can translate this pseudocode into real code for each index from I plus 1. So for... Can you do in Python, can you set the inner for loop also to I? I'm not going to, but I'm going to set it to J in... hold on. For each index from I plus 1 to the end of the list. So for J in range I plus 1 to length of nums, then if the number at the inner loop index, so if nums J is smaller than smallest IDX, then we're going to, it's inside the brackets scope, so you shouldn't be able to use the same name variable. Name shouldn't be, yeah, okay, that's what I thought. Thank you for clarifying. If the number at the inner loop, where was I? Set smallest IDX to the inner loop index. Okay. Hold on one sec, sorry. Work. Oh, good. Set smallest index IDX to the inner loop index. So smallest IDX equals J. Wait, to the inner loop index. Yes. I think that's right. Then we need to swap the number at the outer loop index with the number at smallest IDX. So we can do that with nums I, comma, outer loop index with a number smallest IDX equals smallest. No, wait, I need to do, hold on, idiot. Oh my gosh, I should learn how to type one day. Equal, I think this is right. I think I'm getting there. Besides, the nested loop would become unreadable. True. True facts. EDX and nums I. I think that's right. And then return nums. The only thing I might have messed up is, oh, well, that's spelled wrong, so that's one thing. Is that right? Let's find out. Oh, I failed. Hold on. Whoa, we didn't do anything. That's why. Because what? Let's go back through this. I didn't do anything. Is what the problem was. Oh, wait a second. No, hold on. Hold up. Does that need to be there? Ah, nope. Oh, list out of index range. Okay, I did this last time too, where I was setting the wrong thing. Is it... Do I not actually... If the number at the inner loop... Okay, we're going to go back through this. We did it! This is what I want everyone to learn with me, that I mess up all the time. It's a good time. Okay, set smallest IDX to the current index of the outer loop. So that is correct. Hot dog, happy Thursday. What up, what up? We're going back through and seeing what I blew. Wait a second. That was not accurate. Nobody clipped that one. This isn't my OnlyFans. That's a different day. For each index from I+1 to the end of the list. So for each index from I to the end of the list. Oh, do you have to do... I can't remember with range. Does the length... Does it need to be +1? Is it inclusive or exclusive? In Python. I don't remember. I'm probably doing something else that's stupider, so let me just continue. So if the number at the inner loop index, so that's the number at the inner loop index, yeah, is less than the number at small... Oh. First of all, I think I need to do that. Then set smallest IDX to the inner loop index to nums. I think I need to do that first of all. Oops. I'm still wrong on something. That's fair. Is it... Do you have to do... Oops. Do you have to do this? I can't remember. I know... No, that's wrong. Okay, wait. If the number at the inner loop index... So the inner loop is J. I've gone ahead and confused myself as per usual. For each index from I+1. So this is the inner loop for J, I+1. Yeah. That's fine. Let me just check something. I just want to make sure this is giving me the right thing. Okay, good. 5, 3, 8. So it's starting. So that's all right. Okay. So it's going and then it's getting to 6 and messing up, which means I'm comparing something incorrectly. Hold up. Whoops. Solid X equals nums J. Nums. What is this part? The swap. No, I said don't click it. Alamo. Hold on. Swap the number at the outer loop index. Oh. Wait, no. Swap the number at the outer loop index, which is nums I, with the number at smallest IDX, which is that. What happens if... What's here? Is it ever getting to this? Print smallest IDX. Is this changing? Okay, good. So that is printing. Num smallest IDX equals num... I did that right. That's the right way to swap, because we've already done that a bunch of times. So what am I messing up? I'm just messing up the... Num smallest index equals an index error list index out of range. So I'm just messing up the range. I'm messing up something in here. I'm messing up... I thought it... Maybe... Is it... Do you have to do +1? Let's find out. Let's try again and see what that error was. If nums J... no. So yeah. So that goes too far. Okay. So for each index from I+1 to the end of the list, for each index from I+1, I feel like I'm doing this almost accurately. I feel like we're very close. I'm just missing something. I'm going out of range, so I'm doing something in my list that is wrong. Okay, I just want to try something silly. No, that doesn't help. I'm going out of range. Why? What happens if I just do this? Is that what I need to do? Is that why I messed it up? No. Son of a basket weaver. Oh, why did I get a 4 though? So that's weird. Oh, because that's the index. 0, 1, 2, 3, 4. Which is number 1. Which is accurate. Oh, I'm so close. I'm messing something stupid up. Oh, always the case. Always the case that I'm messing something stupid up. But what is the stupid thing that I'm messing up? Okay. It goes through here. It gives me that. I'm going to do a lot of print debugging for fun. Because it's the best. And if you do it any other way, whatever. Okay, what happens if I do that? So what do I get here? So, okay, that's good. So I'm just making sure this is right. It's printing the 5, then the 5. That's all good. Okay. Then that 4 is the index. Nums. Okay, if the number at the inner loop index, which is J, is less than the number at the smallest index, then set smallest index to the inner loop index. I think that's what I'm doing by setting it to 4. Then swap, but so why am I going out of range here? Set smallest index to the current index. It's a number at the inner loop index. Yeah, okay. We're close. I can feel it. I can also tell that my brain is fried and not working, which is standard. Standard stuff. List index is out of range. Which part is out of range? What if I do this? Oh. That's why it's out of range. But that shouldn't matter. Wait, why? I shouldn't be doing it in the inner loop, though, right? Does that make sense? Okay, well, hold on. Let's see. What did we do here? We didn't swap anything. So that can't be right. That just means that line never hit, did it? Which makes sense. Oops, it wasn't gonna hit based on what I was doing. But now I just need to try something. Just to make sure. That should give me the same result, right? Yes. Okay, so when it does have to be here. Did I spell something wrong? Nums I. So this is the nums I. Wait, hold on. Swap the number at the outer loop index with the number at smallest IDX. Swap the number at the outer loop. That's what I'm doing. Right? Okay, let's try something smaller. Let's try something sillier. Print nums I. Will that print every time? No. Okay, so my I is going out of index. Why? Why is that happening? Do I have to do a range here? Am I just a fool that should have done this the whole time? Nope, that's not right. Oh, I spelled range wrong. Oh, okay. List object cannot be interpreted as an integer. Oh, yeah. That's right. Length of nums. I just want to see if this works. Is this what I'm supposed to be doing? Oh! Okay. Okay. Now let's bring this back. Oh! Yes! I'm just an idiot. Standard. Oh, because for I in nums... Oh, because now if I do this, that's printing the actual index. And when I had it like this, it was printing the actual numbers. Of course. Okay. We got there, people. Oh, that was so stupid, though. What a dumb. But check it. We did it. Man, nothing beats this feeling. Like, I mean, maybe some things, but like, this is a pretty great feeling. I absolutely love figuring it out. That wasn't so bad. No, that wasn't too bad, dude. This is better than sex. I mean, it can feel that way sometimes. It's just so like, it is so addicting to solve a problem. I don't know. I don't know how people don't enjoy it. If you don't enjoy solving a problem, I don't even know what to say. Like, it is just, it makes you feel so good. Also, Alavo, I think I just got I see a Twitter notification. Thank you for sharing that clip. You son of a... man. Yes, though. That felt so good. All right. I should do submit. I do this to myself a lot where I get super cocky because I do like the test run. And then when I go to press submit, something gets messed up. And then I'm like, ah, shit. I shouldn't have been so excited. So let's see what happens. I get anxiety when I solve problems. I get nauseous and shit, but I'm working through it. Do you really? Alavo, I never know if you're just shit posting or not. So, you know, if you're being serious, I'm sorry to hear that. That would be hard. I get anxious if I'm on a deadline and I can't solve a problem, but also because of, as everyone knows, because I keep not shutting up about it, because of my ADHD, that is definitely like I 100% have that, like, anxious deadline, need to get it done, focus mode. It's why I also leave most of the things that I need to do until the very end, which is not helpful. It turns out that's actually not, I don't know how to tell you guys this, but leaving things until the last minute is actually not very helpful. You should try and do them beforehand. It's very frustrating to do things at the last minute all the time. You should not do that. I do it all the time, but you should not do what I do. Unless it's solving selection sort, because this guy rocked it. Heck yeah. God, that feels good. Why do today what you can do tomorrow? Exactly. What's horrible, though, is like, that is legitimately how my brain often works. Is it's like, I'll start the day with like, okay, I want to do this. I'm going to get this done. I've got all day to do it. There's nothing stopping me from doing it. And then I just will not touch it. and I'll go through the whole day. And then you get towards the end of the day and then you start feeling guilty and you're like, why didn't I do it? I had all this time. Now tomorrow I'm not going to have any time, but I still need to get it done. And you start panicking. And it's just so stupid. But I do it all the time. So what are you going to do? But I am very happy that we solved this problem. Now, how close was I to the actual solution? What did we do different? Oh, nothing. Just different naming convention. Oh, yeah, because... Oh, you don't have to do 0 with this. That's a cool pickup. I'll remember that for next time. And then I know Lane really likes to do these spaces, which is why I always get this wrong. And then an extra space for some reason. Wait, that's... Oh. Anyways. There we go. Honestly, I just can't give a bloop about stuff. I'd rather go homeless than do... Dude, I mean... You know what's funny, though? I guess it depends. Like, do you mean, like, do stuff for people as a job? Or, like, do stuff for people because you just want to help people out? Because, like... I love... the weird thing, I love when, like, acquaintances ask me for stuff. Like, I am much more likely and willing to, like, do something for somebody that I barely know than people that are like the closest to me. I don't know why. I probably need to look into that. But yeah, that happens all the time. For that kind of stuff, I like, for random things, but for work, I get it. Yeah. I like to work. I don't like having a job. I feel you on that one. I like that too. I like working. I am very happy to spend hours doing something random like that is interesting to me. I could work on it for hours and hours and hours. But yeah, having a job is always annoying. I mean, I actually really like my job right now, so that's great. that's been a really nice change. But even still, like, it's still nice to just not have a job. If you can. Oh, how much does my gulping come through? Can you hear it? I can see the little volume meter like jump up a little bit when I do it, but I don't know how loud it actually is. Well, we did selection sort, which means we have completed chapter 4 selection sort. "29 today. Dude, happy birthday. Basically 28-year-old job. Best job I had, lasted 4 months. Basically 28 years without a job. Oh, man. Dude, I don't know how you do it. I mean, I'm assuming you still work, like you said. You just don't have, like, a job. Like a 9-to-5er. I've, like, always had a job. Oh, there you go. Well, that'll do it. I mean, that's still a job. All right, I'm moving on. We're done selection sort. We're done sorting algorithms. And our next chapter is polynomial exponential time. Oh man. Excuse me. That is terrifying. I don't know if I'm ready for this. I'm nervous about this one. Oh, excuse me. Oh, I might also just die right now. Okay. Let us continue with this. Okay. Polynomial versus exponential. Broadly speaking, algorithms can be classified into 2 categories: polynomial time, exponential time. So there is a beautiful chart of polynomial time and exponential time. Yeah, Unc, I'm about to shave and hit this gym. Dude, thanks, man. Always appreciate you stopping by. For real. I'm gonna keep trying to go. If I do another stream tomorrow, that's 2 full weeks without missing a day, Monday through Friday. Gonna try and keep that going for at least a month. I mean, I want to just do it forever, but if I can do it for a month, I think or 2 months, really, I think I'll be in a good habit. So that's the goal. Have a good gym, man. I should do a stream from the treadmill at some point. Just walk on the treadmill the whole stream. That would actually be fun. Need to build like a little over the handles desk for my laptop. That could actually be a lot of fun. Now I'm thinking. Now we're thinking. Okay. Polynomial versus exponential. So technically, O(n) factorial is factorial time, but let's lump them together for simplicity. Okay, fine. An algorithm runs in polynomial time if its runtime does not grow faster than n to the k, to the power of k, where k is any constant. Okay. N squared, n cubed, and n is the size of the input. So faster. HK Perf, what up? How are ya? How you been? Dude, we just got done sorting algorithms. Crushed it. It's pretty good stuff, man. Pretty good stuff. Hold on, now I'm just checking something. sorry, dude. I just got caught up in something. All right. Here we go. We're continuing. Okay. Any constant, and n is the size of the input. Polynomial time algorithms can be useful if they're not too slow. In comparison, exponential time algorithms are almost always too slow to be practical. However, sometimes you're trying to force someone to be slow, like in the case of cryptography and security. Even when n is as low as 20, 2 to the power of n is already over 1,000,000. There you go. Good old cryptography. I don't know if Boot.Dev has any cryptography courses, but that would actually be a lot of fun too. Okay, so, were you coming in to answer my question, HK Perf? I just realized what you were doing. I'm sorry, I was still reading. I hadn't even looked at the question yet. I didn't know what you're talking about. That's awesome. I was sitting there like, faster. Yeah, I mean, I'm going as fast as I can. What do you want from me? But yeah, now I understand. You were talking specifically about the question. So polynomial algorithms are faster than exponential algorithms? I don't know. What did we just read? Polynomial time algorithms can be useful if they're not too slow. In comparison, exponential time algorithms are almost always too slow. So, slower, more complicated, less complicated, faster. Let's go with 4. HK, baby. Good answer. Good answer. All right. Let's move on to the next one. Polynomial time equals P. Back in the 1970s, some computer scientists wanted to come up with a good descriptive name for the set of polynomial time algorithms. After much deliberation, they settled on the letter P. Naming things is hard. I'm interested in what this is. XKCD comment. I knew it. As soon as I read what it was, I was like, it has to be an XKCD. So we're going to look at it. Because everybody loves XKCD. Wait. Configure the network. Please enter the host name for the system. You've been staring at that screen a while. Picking a good server name is important. And yet you settled on Caroline for our daughter in like 15 seconds. But this is a server. Besides, I had to. You were trying to name her Epidural. Those were good drugs. Oh, XKCD. Always good. The hand-wavy takeaway is that problems that fall into class P are practical to solve on computers. Problems that don't fall into P are hard, slow, and impractical. Wait, is that where P equals MP problem comes from? I've never looked into it. I've just always like, I know I've heard that before, but is that where it comes from? Polynomial. The point is that you're trying to figure out if polynomial does equal whatever NP means. Is NP not polynomial? Now I have to look into it. Let's do some research. Here, we'll do this one. What does P equals NP mean? Side quest. Come on, Gemini. Smarten up. I wonder if it's gonna draw a picture because I didn't change it to a new chat. The question of whether P equals NP is arguably the most famous unsolved problem in theoretical computer science. At its core, it is a surprisingly simple question. Oh! I was right. I mean, I was getting... I just didn't know exactly... I didn't know it was non-deterministic. Oh, no, I'm doing my face. That's awesome. These are problems that computers can solve quickly and efficiently, even if the size of the problem gets larger. What is NP? Easy to verify. NP stands for non-deterministic polynomial time. These are problems where it might take an incredibly long time to find the answer, but if someone hands you a proposed answer, you can quickly and easily check if it's correct. The classic example. Think about complex routing logistics, like trying to find the absolute most efficient route for a fleet of cold chain freight trucks hitting dozens of cross-border stops. Calculating the single most optimal route from scratch among trillions of possibilities is incredibly slow and difficult. This is the famous traveling salesperson problem. However, if someone hands you a specific route and asks, is this route under 5,000 total miles? You can simply add up the distances and verify it almost instantly. Sudoku, interesting. Complex Sudoku board is hard to solve, but if someone hands you a completed board, it takes only seconds to verify that no numbers repeat in any row, column, or square. Nice. Well, there you go. And then it gets into the whole P equals NP. So it's polynomial time. We learned something new today. That's why we're here. Oh, that's really cool, actually. I did not, like, I'd heard the problem before. I knew the like general part of it, but I never really paid attention to the fact that that's what it has to do with, is the P is polynomial time. Awesome. Algorithms in P are blank than algorithms not in P, are more practical to solve with computers. We're crushing it today. All right, reduction to P. Let's take an exponential time algorithm and fix it up so it can run in polynomial time. The Fibonacci sequence, fun, is a sequence of numbers where each number is the sum of the two numbers before it, like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on and so forth. We want a function that, given an index in the sequence, returns the Fibonacci number at that index. There's a bunch of examples. So Fib2 is 1, Fib4 is 3, Fib6 is 8. Got it. Here are the implementation details to do it in polynomial time. The input n represents the index of the desired Fibonacci number. If n is less than or equal to 1, then return n. Initialize three variables: grandparent equals 0, parent equals 1, and placeholder current to store the new Fibonacci number at each step. Write a loop that iterates n minus 1 times. For example, if n equals 2, one iteration occurs. Inside the loop, set current equals parent plus grandparent. Adjust the ancestor values parent and grandparent to maintain the sequence. Once the loop completes, return current. Woof. Hold on, I need some Diet Coke after that one. Diet Coke and water. Gotta double up on the drinks. Gotta hydrate. Oh. My goodness. Okay. The assignment. Here we go. Our data scientists at LockedIn have found that the growth of the average influencer's follow count is roughly the same growth rate as the Fibonacci sequence. In other words, after 6 weeks of good social media posts, the average influencer will have 8 followers. After 7 weeks, 13 followers, and so on. The trouble is, our current implementation of the Fibonacci function takes so long, exponential time, to complete that when our influencers navigate to their analytics page, it often never completes loading. Adjust the fib function using the given algorithm to achieve polynomial runtime. Okay, let's see. So it basically, here are the implementation details to do it in polynomial time. We need to take this, and we're basically rewriting it into this. So I'm going to leave what they have here and try just starting it from here. So the input n represents the index of the desired Fibonacci number. So that's the index in a list. Got it. So if n is less than or equal to 1, then return n. Then initialize 3 variables. So grandparent whoops, grandparent equals 0, parent equals 1, and current equals... This is going to be a placeholder. So... there's a way to do this properly in... There's a way in Python to just set an empty number variable. It's just like that. Is that what you... anyways, I'm just going to do this. I'm going to do... What if we do float infinity? I know... Okay. There is a way to just do a placeholder, and I can't... Is it none? Is that what you do? I don't know. We'll try that. I know there's a way to do it, and we can look it up after. Oh, now my eyes are just bugging out. 4. Write a loop that iterates n minus 1 times. So 4 I in n, range 0 to n minus 1. Then inside the loop, we set current equals parent plus grandparent. I spelled parent wrong up here. That's good to know. Okay. Adjust the ancestor values parent and grandparent to maintain the sequence. Once the loop completes, return current. Okay, hold on. Hold on 1 second. Work. Uno momento. Do you know if the responses from the TCX pages are routing properly now? As of right now... Hold on 1 sec. I just got to respond to something. As of right now... Okay, I might have to go one more time. I might get a call. If I get a call, that's actually more of a nightmare. I have to change a whole bunch of stuff. But I can do it. Let's see if we can finish this first, though. Inside the loop, set ask quasi directly if you need somebody city tackle it. Okay, cool. Cool. Oh, sorry, guys. 1 second. All right, so let's go back to this. Adjust the ancestor values parent and grandparent to maintain the sequence. And so I need to, let me read back on, I felt like I read this more clearly earlier. Adjust the ancestor values parent and grandparent to maintain the sequence. What does that mean? What does that mean? Do I just add 1 to each of them? Adjust the ancestor values, parent and grandparent, to maintain, and then once it finishes, return current. So return current is where we're going to end up. Current equals parent plus grandparent. Adjust the ancestor values to maintain the sequence. So it's going to be parent plus equals I. Let's try this. I don't think this is right, but We're just gonna try it and see what happens. All right, what happens? Fail. Nope. So we weren't there. We were close though. Parent, grandparent. We just need to do this more properly. I'm gonna print all this out because I want to see what happens. Print parent, print grandparent, print current. Because I just want to see how this actually looks. So it goes expected 1. So it's printing. So the parent is 1. The grandparent is 0. Then the current is 1. Then there's 20. Is there a shorter one? No, 1, 1, 1 doesn't help me at all. 1. Okay, so wait. 1, 1. Current is just wrong. I'm doing current wrong. What am I doing wrong on current? Let's read through this one more time. Once the loop completes, return current. So so current ends up at, oh, at 57, and in this one it should be 55. So it's adding, what is it adding incorrectly? What are we missing, folks? What are we missing here? We're missing something. We're missing something. Let's think through this a little bit more. So grandparent equals 0, parent equals 1. Do we just want to add 1? Is that all we're doing? I don't think that's right, but I'm just going to try this just to see what happens. Okay, yeah, that's definitely wrong. That's fair. Is it? No, times won't work because that'll be 0. N represents the index of the desired Fibonacci number. Is it? Once the loop completes, return current. Okay, we're close. We're always a little close, but I'm doing something stupid. So for I in range, is it? Oh, wait a second. Do I need to do write a loop that iterates n minus 1 times? This is your first live? No, I've been doing them for a little bit. This has been, I try and do, I go on and off. I got like a year and a half ago I started, and I was doing pretty well for a couple months, and then I bailed. And then I've been, the last 2 weeks, my goal is to do it every Monday through Friday. But this is my 9th one in a row. So we'll see what happens. And I'm just trying to figure out what I messed up here, because I definitely messed something up. Return n. Grandparent equals 0, parent equals 1. So, okay. Grandparent equals 0. Parent equals 1. Grandparent. That's fine. They should both be incrementing. What am I missing here? What am I missing? And just to make sure, if I print n, it's just a single number, right? Oops. N is just a single number, yeah? Okay. It's just the number that we're given. So that makes sense. So, if we get 10, for I in range, I just want to try this. This is silly, but no, that's not it. Good. I'm glad that didn't work, or else I would have felt annoyed. Can I just do this? I don't think I have to set the 0, do I? No, that still does the same thing. So that's good. That's good. Still does the same thing. We don't need that. We just need parent equals grandparent. Is that what it is? And then what's grandparent? You can try it. And current equals parent? Well, wait. Adjust the... Should current be parent or should... Or sorry. It says... Because it says to do set current equal to parent plus grandparent. And then so... Do we do... Grandparent... Because if I do current equals parent right here, that what will that do? Let's find out. No, I think because that just resets the same thing. If it's grandparent, what happens if I do that just for fun? Let's just try things. Parent equals current, like that, because that would be weird. Ah! Grandparent equals parent. Okay, let's try that. Grandparent equals, like, do you think it's gonna be grandparent equals parent and then parent equals current? Okay, I'm on. I like what you're doing. Yeah, nice one. That was good. Oh yeah, that makes sense. That makes sense because I should have been thinking about the fact that if it moves up the list, I'm not trying to move it by the index. I'm trying to move it by the actual. Thank you. That was a really good suggestion. We got it. Let's submit it and see if it works. Hey, nice job. Okay. Good job. I don't know how long it would have taken me to get there, but that's part of the fun. Just so you know, a lot of my stream is just me being an idiot and trying to figure things out. And it's a lot of fun for me. So I love doing development. I've never done anything like I love coding for fun in my spare time. I've never done it really other than in, you know, front end web dev stuff for the most part. And then I've made some games, but I was like, I've always wanted to get better at it and just learn more about some of the more complicated things that I've been able to avoid and still be able to do stuff. You feel seen? Hey, that's what we're here for. Yeah, I've always loved development, and it's never been my career path. It's never been my main focus, but I've just always enjoyed it. And so a couple years ago, I found Boot.Dev and I started doing it. And I also always wanted to stream. So I was like, this seems like a perfect way to force myself to do it. And so I started streaming and doing Boot.Dev. And it is an awesome, I'm not sponsored by them. I mean, I know, for what it's worth, I know Lane, who started it from Twitter, but like, I don't know him personally. But I really like what they've done. It's really, really good. It's expensive. Like, you know, there is a reasonable cost to it. But when I actually sit down and do it, I really feel myself getting better. Oh, you're into ML research. Nice. That's cool, man. Good for you. I mean, that's a good field to be in right now. I do marketing, so I've always done marketing as like my main career, but I've always liked computers. I've always thought streaming was interesting, and so I was like, hey, can I figure out how to figure things out? Hold on one sec. Sorry, just got a work request. Yeah, that's perfect. You're getting started. Good for you. Sorry, one second. I have kids and a job, and so I'm trying to squeeze everything I can into a day. And the only way that I found to do it is to just start streaming, but then I'm like, I also have to stop and do real work whenever something comes up. But I try and work like early morning to get ahead, so that way it's really just by the afternoon. If I get anything, they're just some like last minute requests, and then I can always do more work later in the afternoon. So, you know, try to figure it out. But that's cool that you're doing ML research. Are you just learning it by yourself? What are you using to study? Did I submit this? Yeah, okay. There we go. Oh, snap. I wasn't ready for this. Oh man, all of a sudden it is very hot in my house. Did the heat come on or something silly? I know I am wearing a sweatshirt, which is not always a great choice, but wild. I completed my graduation and job hunting. Nice, good for you. Self-studying, that's awesome. Well, that's all I've ever done. I've made a few games like in my time. I've coded a few, I've built a whack of internal tools. Some of the stuff, like a lot of the stuff I did before AI, and then with AI, I've done a lot more now because you can. I can do it while maintaining a regular job and just, tell the AI to go build something and then I can come back and use it. And that's been really cool. But yeah, I'm all self-taught, and then I've tried a bunch of different courses. I've done like, yeah, I was gonna say I've done like Coursera, I've done like Udemy back in the day. Boot.Dev has been the one that I have found has helped things that I've learned stick the most. But I mean, that could also just be from getting a little bit older and having more experience, because I've done more of these things now over time, and they slowly have compounded into some level of knowledge. But I'm still quite terrible, don't get me wrong. Yeah, that's smart, making small projects. Good for you. Do you talk about them? Like, do you go on Twitter or something and like share them and talk about them? Because man, I'll tell you, that is the fastest way to get a job. If you just go on and start sharing your stuff, and if you're already doing that, awesome. I don't need to belabor it, but if you're not, just do it. Share anything. Share everything you're working on. Like, it's a great way to find freshers job. And yeah, honestly, like I would just get on Twitter or X or whatever you want to call it, and just start talking to people. There's so many really talented developers on there that have great reach, and if you just start sharing what you're doing, if it's cool, I mean, people start talking to you. Yeah, I would do like LinkedIn's fine. There's nothing wrong with being on LinkedIn, obviously, but there's a great developer community on Twitter. I mean, it's kind of what pushed me into doing streaming. Is like I'd always wanted to do streaming, but I didn't really know what to stream. And then I found a bunch of developers, and I was like, you know what? Some of these developers are already really talented. Maybe I could be somebody that comes on and is not very good. can just show what it's like to not be very good at coding and other things, and just, try and just be like, look, anybody can learn. Like, I'm learning stuff, so anybody can do it if you're interested and you're willing to put in a little bit of time. And so it's been a great excuse to do coding and also stream. So, but I ended up going to I went to a conference just recently that was a developer conference that was awesome, and got to meet a bunch of people that I'd been talking to online for a long time. But yeah, that loop of somebody's already made it, I'm not adding any more value. You got to get out of it. Like, just don't think that way, because all you're doing is sharing what you find interesting. Just think of it that way. Like, just be like, I'm just sharing something that I think is cool. You don't have to be out there trying to talk it up like it's the world's greatest thing and it's gonna revolutionize the industry or anything like that. Like, you don't need to be annoying about it. You can just be like, hey, I built this. This is something that I made. This is why I made it. And then, as always, with like any social media, be social and like talk to other people and have fun. Like, I don't know. I post ridiculous things. I am very much a person who just posts whatever comes to the top of my head, and it's all over the place. But, don't get into that loop. It won't help you. And like, what's the worst that happens? Like, you share something and someone's like, oh, somebody already built that. You're like, so what? I don't care. I built it because I wanted to. If you don't like it, that's fine. You don't have to defend it. You don't have to get into arguments about it. You don't have to prove that it's better. Like, just share it. And what will happen is you will get feedback, and they'll either say, like, you'll either start to get some good feedback, and it'll be like, oh, maybe I built something cooler than what people expected or what even I knew I was building, or you won't. But your name will get out there and you'll start getting into conversations with people. And I'm telling you, if you're just be a friendly person. I mean, you don't always have to be friendly, but like just be a person that people want to talk to, and eventually, I guarantee I would be. If you are reasonably talented at development or ML, even if you're not an expert, like you don't have to lie about being a pro. Again, what I'm trying to showcase here is like I don't come in and be like, I'm going to teach you everything you need to know about coding. I'm like, I don't know anything. I know basically nothing, but if you want to join me on this journey, we can learn together and it can be fun. So I would just do that. Like that's my best advice, is just be you and have fun and post stuff that you're working on. And I would be shocked if you found a job any other way faster than just by doing that. I had a prompt engineering job in my third year of graduation. Really? That's wild. Did that stay as a job, or is that done? Like I remember when prompt engineering came out as a career, but it seemed like that kind of went away quickly. I don't know if it's still a job or not, but that's cool. You could talk about what you learned. Make some cool prompts on the new ChatGPT and just share it and be like, look at this ridiculous dumb thing I made. I don't know. It's not easy to put yourself out there in the beginning, but I promise you, I feel very comfortable saying that, like, if you want to get a job in the industry, making sure that people can see the stuff you're working on is going to get you a job faster than anything else. There's no clarity to even team leads. That's amazing. I mean, yeah, AI obviously is changing super fast every day. Nobody really knows what's going on. That's hilarious. Oh, hold on. I have to share something that I think is really funny. Hold on. Oh my gosh, I just forgot what I was doing. I'm trying to take a screenshot of an email. On my LinkedIn page, I have HTMX CEO, because it's just a silly joke on Twitter. But because I have CEO of HTMX, every once in a while I'll get emails that are like, do you want VC investment into HTMX? It's like, bro, this is obviously random because you have no idea what you're even talking about. Need to bring it up to the rest of the CEOs. Use CEOs for a quick vote. We've been offered some new VC funding. What do we think? Should we proceed? This is what it's about. It's like, just have fun, be silly. If you're a silly person, if you're a serious person, be serious. Like, it doesn't matter. Just do you. That's all you need to do. Where do you work, by the way? I work for a company that does commodity trading, but I'm in Canada. Or they do, so we built a platform for commodity trading. So that's what I do for my day job. And then I do this just for fun. Maybe one day a day job, who knows? You know, maybe we'll get lucky. But for now, yeah, this is, I just like to stream for fun. And so yeah, we built a platform that helps with commodity trading. So we do like fresh and frozen, fresh and frozen poultry, chicken. Oh my gosh, my brain's not working. Poultry and chicken. Yeah. Poultry and pork and beef and all sorts of different things. And so you're in India. Oh, nice, dude. Hold on one sec. I'm almost done. I just need to share this. And then we're going to get back to it. We're going to learn order k to the power of n exponentials. It's going to be great. We will figure it out as we go. Let's hide the guy's name because I'm a nice person. Okay, we're almost done. You know, I've never been to India. My father-in-law, he works for a rail company, and he's a developer actually, and they go to India. He goes to India. He used to go to India all the time. I don't know how much he does anymore, but does it matter? I don't need to do this. Whatever. Oops, I didn't mean to save that. Oh well. Almost done. I really should have done this on a computer. I could have let you see it. It wouldn't have mattered. Oh my gosh, I am gonna lose my mind while I'm trying to do this. I'm trying to do like the simplest thing, and the world of Apple is pissing me off right now. I just want to post this for fun, Apple. Leave me alone. Whatever. Here we go. You know, once in a hackathon, I worked on a blockchain project related to commodities. Oh yeah, that's cool. How was that? Was that fun? Are you into a bunch of other blockchain stuff? All right, here, we're gonna get back in just 2 seconds. I'm gonna get back on doing this course, but that's cool, man. I've always wanted to do a hackathon. One day. Oh man, time's flying. Holy jeez. So just so you know, I usually go from like 3 p.m. to 5 p.m. Eastern, so that's, I have like another 40-ish minutes is what I try to do. I'm just trying to build the muscle of like remembering to go stream every day. It's kind of the main goal right now. I mean, it was just an idea. I didn't really continue with it. I mean, that happens though. That's what hackathons are for. They're just for fun, right? But I would like share that stuff, like write about it. What did you learn? Did you have fun? Like all of that stuff. The more you can just write about your experience and what you're doing and just post it out there, the better. Like, I guarantee you, that's the last time I'll say it, but I promise you, like, that is the way you're going to get a job more than anything else. Just made the basic database and the time ran out. Oh, yeah, that's that's rough. That's cool, though. Like I said, I've always wanted to do I should do a hackathon sometime. That would be fun. I'm into it. I'm into the idea. Okay. I'm going to get back into this course. Let's see what we can do here. So, O, k to the n, where k represents a constant branching factor, as an example, 3 to the power of n, is the first big O class that we've dealt with that falls into the scary exponential category of algorithms. Algorithms that grow at an exponential rate become impossible to compute after so little scale up that they're usually almost worthless in practicality. Letter combinations of a phone number. Locked-ins, oh man, just seeing this T9, this T9 numpad, man, I was so good at T9 back in the day. I could type text messages with my phone in my pocket. I was on fire. Locked-in's advertising team wants to help influencers launch paid campaigns using vanity phone numbers. Think 1-800-Flowers. In order for this to work, we need to be able to take a phone number and calculate all possible sequences of letters that it could represent. Then the ad team can give influencers numbers that make brand-friendly words. Oh, man. So each digit can represent 3 or 4 different letters. For this reason, the number of letter sequences... I just want to press these buttons. I want to press these buttons so bad. Are you saying what to my T9 ability? Or are you so young that you're like, what is T9? Because back when I was a young buck, that's how we used to message, man. Yeah, that's so funny. I mean, it makes sense. I'm almost 40, so like I get it. But when I was in university, like I had a T9 even before then, but I remember when I was in university, I would like go to the bar, and I used to do this silly trick with girls that I would be like, give me your number and I can send you a message from my pocket. And they were like, whatever, you can't do it, blah, blah, blah. But I had done so much texting with a T9 that like all the sequences and like how the buttons felt on my phone were just like complete muscle memory. And so I would just like get their number, put my phone in my pocket, and then send them a text message, and they would be like blown away. They're just like, what? How were you able to do that? It was so stupid. It was a pretty good pickup line though. Back in the day, you know, back before touchscreens were all the rage. Holy bar trick. Yeah, man, it was pretty good. That was it was fun. You can't do that anymore. I can't text with my eyes closed on a touchscreen. It doesn't have that same tactile feel. It's a little more difficult. Oh, thank you. I don't know if it's impressive or just sad that all I used to do was text people all the time. I loved when text messaging like came out. It became, I mean, I was a kid of like the AOL and ICQ age. Like typing to communicate has been my like whole life. And so when I could like do it on my phone, I was like, this is amazing. And I would just do it all the time. All the time. All right, let's keep going on this. Each digit can represent 3 or 4 different letters. For this reason, the number of letter sequences associated with a string of digits grows very quickly as the number of digits increases. The possibilities either triple 3 to the power of n or quadruple 4 to the power of n with each digit. Okay, so as an example, the number 6, possible letter sequences, there's 3 of them, M, N, or O. 6, 7, there's no way Lane didn't put in 6, 7 on purpose. But that's 12, MP, MQ, MR, and all the other ones. 6, 7, 8. Prefer texting over calling? I do too. I get it. 36, 6, 7, 8, 9 is 144. 3, 4, 5, 6, 7, 8, 9 is 3,888. A 7-digit phone number will produce between 2,187, 3 to the power of 7, and 16,384, 4 to the power of 7 letter sequences, though usually closer to the low end of that range, which makes sense because if you look at a phone, most of them are 3 digits. It's a good thing phone numbers are short. If you had a 32-digit phone number, it could form at least 1.85 quadrillion letter sequences. Dang. All right. Assignment. Complete the letter combinations function using the algorithm outlined below. It takes a string of digits and returns a list of strings of letters. Where are you solving these questions? So, you just solve them over here. So I'm gonna I'll end up doing all the code over here, which is fun. So like I obviously haven't started yet, but they just use a REPL, which is great because you can just do it right in here, and it's got the tests written and everything. And then yeah, but I would Boot.Dev, man. It's a great, like I said, it's not cheap, but it's like, I don't even remember the price, but I think it's like $400 or $500 for the year. But you learn a lot, I think. And they do have a whole bunch of free courses though, like if you wanted to go check out. And on their YouTube channel, Lane is always putting up like really in-depth videos that are like full courses that you can watch. And then, you know, obviously if you're just watching those and you wanted to do any solving, you'd have to use your own IDE or whatever. But Yeah, leak code's great too. I mean, if you could do leak code, that's cool. I'm not at leak code level yet. I still need to learn a bit more of the basics before. I tried leak code a couple times and I was just like, oh shit, this is too much. And it was like, oops, I am not good at this. And then I remember, I don't even know how I got the opportunity. It was totally random. I think I reached out to some, I think I reached out to like Dropbox and I was like, I'm terrible at code, but can I have an interview? And for some reason they were like, okay, just do this like leak code style exam. And I just bombed it. I just bombed it so bad. And I was like, oh yeah, I'm not there yet. I still need to learn more about developing. Yeah, they do have some basic ones. I know. I've become very much enamored with the Boot.Dev situation. It's really good. Okay, let's see what we can do. If the input string is empty, return an empty list. I'm gonna try and do this while we go through the list. I don't usually do that, but I'm gonna try this time. So if digits with Python, can you do is empty, or is that a real thing? Hold on, I want to try something. Print yes. No, okay, it's not right. Okay, if digits, I know you could just do this, but I thought there was a better way to do it. Okay, that worked. Well, that's good. Okay. If digits is empty, return an empty list is... Can I just do that? Oh, yeah, I can. Cool. Nice. Okay. Then, what's the next step? Define a result list. Okay, so result equals list. Have it contain just an empty string to start. Okay, so we'll do that. And we need that one element to build on. All right, iterate over the digits for each of them. So we'll say digit in digits. If digit is any valid character, i.e. not found in the provided digit to letters dictionary, raise a value error to abort the function. So if digit in digit to letters, then we'll do that. And oh, do I have to do a try? I think I do. If I have, I think if, no, try. Is this right? I'm just going to leave that empty for a second and then raise value error F invalid digit. Like that. Wait. Oh yeah. Shoot, I'm so bad at remembering how these go. I don't remember how you're supposed to write these. Is it accept? Do you have to do that? Is it like that? Oh, it's been too long. We'll see what happens. I'm probably gonna mess this up. That's okay though. That's what we're here for. For messing things up. Abort the function. So then if it is in there, then we need to get the string of letters that can be represented by the current digit from digit to letters. So we need to get the value from the key. So we need, what do we want that to be? Get the string of letters that can be represented from digit to letters. Okay. So we need letters equals digit to letters digit. That makes sense. And then define a new I know I'm doing this wrong still. I know I'm doing this the whole error handling wrong. I know I am, but that's okay. I'm just gonna keep going, and then we'll come back and fix it. Get the string of letters. So then get the string of letters that can be represented by the current digit. We did that. Define a new result list, empty to start with. So new result, empty. Then enter 2 nested for loops. Oh my goodness. So for each existing letter combo in result, iterate over each letter in the current digits letters. Oh my god. Okay. This is getting intense. So we'll say for I also haven't tried try method in these questions. Yeah, we'll see what happens. We'll see what happens. Or for each existing letter combo in result, iterate over each letter in the current digits letters. So for each existing letter combo in result, oh my gosh. For each, why can't I even understand this sentence? For each existing letter combo in result. So okay, so we're starting with this and there's nothing. So for I in result, we need to iterate over each letter for J in, well here, we can do letter in letters. And then each letter in the digits current letters. Append combo plus letter to new result. Where did combo come from? That's what's throwing me off. For each existing letter combo. Oh, is that just what he's calling this? For combo in result. For letter in letters. Append. So new result equals. Oh, new result dot append. Combo plus letter. Whew. Okay, after the 2 nested loops, but still inside the main loop. That's here. Still inside the main loop. Still inside the main loop. Loop over but still inside the main loop over digits. Set result equals. Can you show the input output example? I will. I have to do when I do run. We'll just see what happens. It'll show one. But I feel like I try to get through the whole thing and then see what happens. I like to try and just do it and see what comes out and then be like, okay, this is right, or I'm close, or I'm totally off. Then we see what happens. But we'll try it. Don't worry. We're almost there. We're almost there. Where was I? Result equals new result. Okay. After the main loop, return result. And then return result. Okay. Other than the try except, I think I'm pretty close actually. Oh shit, I got it. Yes! Did we just one-shot that? Okay, so this is where it gets nerve-wracking because I'm pretty sure this one probably didn't have anything to like trip me up. Oh, it did do the, because I can see that I didn't actually raise any errors. So that's where it gets nerve-wracking. So when I press submit, we're gonna get the first one to see if we actually did this properly. No, we failed. Ah! I knew that was gonna happen. Dang it. So we failed. Which one? The value error. Yes, I figured that makes sense. Do we just return value error? Is that what it wants me to do? No, shit. I knew I wasn't doing this value error right. I was 100% sure that I wasn't doing this right, but I am very happy that everything else worked out. I don't remember how to do this. I thought you could just do this. But that's obviously wrong. I just don't remember how to do it. Oh, I remember now. Because of this is something, I think this is just a weird thing about doing this. I think I just do this. I don't need the try. I think I just need to do this. Shit. For digits. I think I'm just supposed to do that. Wait. Oh, shit. That expected value error. Caught value error. Invalid digit. Oh, because I messed this up somewhere. Hold on. If the digit is any invalid character. Oh, yeah, right. I need to actually write the... I'm such an idiot. Okay. If I need it to be... Hold on. We need to put that... if the digit is any invalid character, we need to put that here. Is that right? Do I need to do an if statement, or will this just catch it? Now is what I... Hold on. Let's just make sure this is still... Okay, that's why. I need to do the if. So, if digit in digit to letters. So, if the digit is any invalid character, not found. So, if digit not in digit to letters, then raise that. That should be it. Oh, you were just writing the same thing. There we go. Yeah, I do this with Python a lot, and I forget about raising errors, and like when you need to write the actual like full try except piece, and when you can just raise the error like that. And then when I do that, it always messes me up because I'm like, I know there's a better way to do it, and I know I'm doing it wrong. And also, though, I could just do this now because I should just be able to do that now too, right? Because I'm checking if it's not in it, and then if it's not, then we know it is. Yeah, okay. See? Hey, we even refactored our code a little bit. There we go. Good job, us. Good job, us. We're crushing it. It's pretty solid. That one felt good. I'm glad we got that one. I'm actually impressed. I will say, sometimes I like to toot my own horn. The fact that we wrote the whole thing, knowing that as we were writing it, that like the try catch was probably wrong, but the fact that we were able to write the whole thing and it worked, basically, was pretty cool. I felt pretty happy about that one. Not bad. I mean, I know we didn't like come up with it, because one thing that I do really like about Boot.Dev is a lot of this stuff while you're learning, Lane kind of writes out this pseudo code that really helps you through it, which is great. Because then you don't panic and get caught up in just the, why can't I figure this out? Or like, what am I even trying to do? It walks you through all the steps in the earlier lessons, especially. Obviously, as you go further, you get less and less detail, but that felt good. Okay, let's see what else we have. Okay, we're probably not going to do these quizzes. I'm going to save those for tomorrow, but we'll do this big O category review question, which is just going to be one question. Then we're going to take a little break and call it a day, because it's almost my time to be done. I think I've got technically like 20 more minutes, but I think I'll probably end it a little bit early, just because I don't really want to get into these complexity quizzes. We could do something else. I could show you some of the games I made if you want to see them. Have you ever heard of something called Pico 8? Yeah, everything is so well explained in the question itself. Yeah, Lane does a great job. They spend a ton of time and money on building these lessons to be really good. And like, when you leave the lessons from Boot.Dev, you learn something. It's 2:11 a.m. there. Oh man, that's wild. I my kids they're going to gymnastics today, but then once they get home from gymnastics, I got to make dinner and get them all ready for the day for tomorrow. Okay, we're gonna do this big O category review. We're gonna answer this question. I'm gonna show you, because why not? I'll show you. If you've never used Pico 8, it is my like thing that I love, and so I'm gonna show it to you really fast. But let's read these first. So big O. O of 1 is constant. It's best. It's the absolute best. The algorithm always takes the same amount of time, regardless of how much data there is. Example, looking up an item in a list by index. O log n is logarithmic. It's a great algorithm. It removes a percentage of the total steps with each iteration, so it's very fast, even with large amounts of data. An example of that is binary search. O of n is linear. It's good. 100 items, 100 units of work. 200 items, 200 units of work. This is usually the case for a single non-nested loop. Example, an unsorted array search. O n log n is linearithmic. Ooh, I don't think they'd said that word yet in the course. Okay, this is slightly worse than linear, but not too bad. Example, merge sort and other fast sorting algorithms. O n squared is quadratic. It's slow. You just notice those books? Oh, I don't even know what's back there right now. I got a whole bunch of random stuff back there. Which book are you interested in? there's a whole whack of different books. Oh man, there's a whole bunch of stuff. It's all over the map. Biographies. There's how to draw. Animation books. Books about programming. I got all sorts of random ones. Fiction books, although not a lot of fiction, to be totally honest. I don't buy a lot of fiction books. I have some, but I mostly get those from the library. But a lot of these are like programming books and stuff. Yeah, I got a whole bunch of random stuff. I like to read nonfiction for the most part. I like to read biographies, things about people. But then the fiction book that I'm just finishing up right now is this one, which is really good. I would definitely... Anything by Neil Stephenson I've really enjoyed. He's the one I'm currently working on. I've got the 2 to 3 programming books. Nice. I've got the the Game of Thrones books. What else I got in here? I don't know, all sorts of weird stuff. I sort of just read random, but I'm not a dude, by the way, just, oh, I'm sorry. Well, I apologize for that. I shouldn't have made an assumption. I'm very sorry. It tends to be mostly dudes that come in and hang out. So I apologize for that. Which genre of books? So I like, the classics. I like science fiction. I like, I think one of my like favorite series of books is like alternative history fiction. So like, I don't know if you've ever seen or heard of the show. There's 2 that I can think of that I really like. There's the TV show Halt and Catch Fire, which is awesome. And then the For All Mankind show that's out right now. I really like where people take something that is like historically accurate to a point and then branch it off and do a bunch of like really interesting different things about it. Like nice. Which show? Oh, you just like that genre. Okay, sweet. Yeah, it's a really cool genre. It's if you like computers and you haven't seen Halt and Catch Fire, if you can find it somewhere to watch, I would definitely recommend it. It's awesome. It's one of my favorite TV shows of all time. But that style of fiction I really like. What about you? What do you read? So obviously you also like alternate history. Do you have a favorite author or go-to? Greek mythology books. Wait, do I have a Greek mythology book? I don't know if I do. I have a weird Greek mythology book. Where is it? I have a... Oh, shit. Sorry, I just knocked my microphone off. I knocked this off. Hold on one second. I had a cool book, and I don't know where it is. But it's like an... Oh, yeah. The Myth of Myths. It's a Greek mythology... It's like an animated book. Or not animated. What am I trying to say? It's a... It's like a hand-drawn... I'll just show you. Because it's pretty cool. Okay, hold on. Let's see if I can pull it out from here. Ugh. I'm going to try not to murder myself with knocking things off my shelf. But okay, this I bought off like a Kickstarter a super long time ago, which I really liked, and which I thought it was cool. But so it's this book, and this person, they did a cool job of, like, they did like these drawings. And what's funny is they actually did this like way before, what's that game? Hades, before Hades came out, but the graphic style was very similar to me. But these are cool. They just like go through all the different Greek gods. I thought that was cool. Native Indian history books, that would be cool. You know what? It's so pathetic, but I don't know a whole lot about India's history, which is pretty sad. I should learn more about it, but yeah, I don't really know a lot about it. Yeah, this book was cool. This Greek mythology book was fun. I do like to say, though, sometimes, oh, you do illustrations? That's cool. But just on my sketchbook. Again, you should share those. I draw a bunch of dumb stuff, and I post it all the time. You like to draw, paint, and read? Me too. Those are good things to do. I also enjoy them. It's, yeah, I mean, it's fun. I mean, it's very rich. Yeah, your history is, I mean, so that's the thing. Like, I don't want to speak more than I actually know about, but like, I know a little bit about it, and it seems very interesting. And there's obviously, it's been a culture that's been around for a long time, but I need to learn more. I'm too ignorant on it. Maybe that can be my next, you know, once I get bored of development and coding, then I can start streaming about Indian history. You also write poetry. That's cool. Good for you. See, like, okay, I know that I've already harped on this for a very long time, but like, go on Twitter and start sharing this stuff. Even your poetry, like all the stuff that you feel comfortable sharing. And it's fun to share stuff that you make. And most of the time people react positively to it. Legit. And just do it. Get your name out there. Cause like, sadly, I do kind of fall into the camp of like, with artificial intelligence, the thing that you're going to have that artificial intelligence can't replicate is an audience of people that you talk with. Like, you know, AI can spam stuff, and at some point it'll build its own audience. But even if AI builds its own audience, it doesn't take away from your audience. Multiple people can enjoy multiple things. So, don't be scared. Just do it. Okay, hold on. I got to finish this because I'm running out of time before I got to go. We're going to get through this. But this is, just so you know, I've really enjoyed talking to you, and hopefully you'll come back. I know this is super late for you, so I don't expect you to come back and watch me yammer on about being bad at development at 2 a.m. But if you do come back, this is the schedule that I've been going on. Although this weekend I might try and do like a late night one, so might be like early morning for you. Excuse me. And the soul of my art. It can't have that either. It can't have the soul of your art. Exactly. And that's why I think like it's important to put that stuff. I don't know. I don't know. I'm in marketing. My whole thing is like, put everything out there. share all the things. Find your audience. Share everything that you possibly can. And like, I'm trying to do it more personally because I've always done it for like work and clients, but I'm like, I got to do this more for myself too. Okay, I'm going to finish this really fast because we're almost done. And then I can keep chatting for a little bit. I was just scrolling on YouTube and found you. I also enjoyed it. Oh, good. That's cool that I came across on YouTube. I'm obviously still very small on all of these channels, which is cool. I like it. I'm just doing it for fun. I hope you do come back. I'm trying to do Monday through Friday, 3 to 5 Eastern time. So, you know, if you're ever bored, I will hopefully be there around those times. That's the goal. If I'm awake, yeah, exactly. It's okay. I can respect the fact that it's very early or late, I guess, probably for you. All right. O(n) squared is quadratic. Slow. The amount of work is the square of the input size. 10 inputs, 100 units of work. 100 inputs, 10,000 units of work. So that's a nested for loop to find all the ordered pairs in a list. O(n) cubed is cubic. It's even slower, as you would expect. 100 items does 100 to the power of 3, which is 1,000,000 units of work. O2 to the power of n is exponential. This is horribly slow, and we want to avoid at all costs. Adding 1 to the input doubles the amount of steps. So brute force guessing results of a sequence of n coin flips. That's interesting. And O factorial, finally, is even more horrible. The algorithm becomes so slow, so fast that it is practically unusable. So the only reason, or one of the reasons you might use an O factorial would be to build a in cybersecurity, right? Because they take a long time for algorithms to break your thing. This is a great chart for speed. And so after reading everything, do you have a guess here? I got my guess. Which algorithm tends to be fastest of all of these? We just went through it. I think I know. I'm feeling pretty confident. What do you think? Even more horrible? Yeah, even more horrible is a great it's a great way to define an algorithm. Which one do you think is going to be the fastest out of that list? O(n) squared, O(n) log n, O(n), or O2 to the power of n? Well, we can see O2 to the power of n on the screen still. And we can actually see all of them, I just realized. But so we're going to go with O of n. Boom. We got it. All right, we did it. I feel very happy with getting through that. We are going to do this complexity quiz later. Oh, wait, are these just questions? Or are these 6 just questions? Hold on one sec. And then 1 assignment? All right, let's do the questions first. We're going to knock these ones out. Consider the following code. Get name at index names I, return names I. That is super fast. That's going to be O1. Boom. Knocked out. Done. I'm going fast. I apologize. Also, excuse me. Oh, too much talking. Need more water. Consider the following code. It calculates the number of times a given number can be divided by 2 before becoming less than or equal to 1. So that's going to be I believe that's O of n, because no, wait. It calculates the number of times. Oh no, so that is going to be exponential? It calculates the number of times a given number can be divided by 2 before becoming less than or equal to 1. So the algorithm is going to get slower. No, it's not. I'm thinking of this wrong. I replied that O1 without seeing options. That's fair. It is log n. You are correct. Good one. Nicely done. All right. How about this one? What is an equivalent but not fully reduced way to express the complexity? Yes, because I should have read the code more, because as soon as I saw that it was dividing by 2, that means it was obviously getting less each time. But I did not read that. I was too busy yammering to myself. So let's do this one. Have sections returns a list of lists. For example, n equals 12 results in those having lists. Oh, so this is like merge sort. So, I mean, it's not quite merge sort, but it's close. So it has a specific time complexity of n plus n divided by 2 plus n divided by 4. Oh, wait. So that's exponential, right? Should we read the hint? It is... Or is it O2n? I want to read the hint. This is a tricky one. You need to take into account the shrinking size of the successive list. So I think it's O2n. Or is it... Because that's the unreduced size. Although it could be log n times log n. Because it's a shrinking list. Three or four? What do you think? Yeah, I think it is. Because the list is shrinking. So that is a log n algorithm. But... What was it? Let's do it. Let's try it. Oh, we got it wrong. Okay, so my first guess originally was O2 of n. But that could be wrong as well. But that was my next guess, so I'm going with that one. Yeah! All right. Because it would have been... Because it's really just O of n. Because that's when they're talking about the fact that it's not... No, it's not your fault. And I don't care. We're just having fun. It doesn't matter to me. The point is to learn. I actually want to explain this one. I want to hear what Boots has to say. Okay. This is the other cool thing. So they built this really awesome AI into this tool. It's been like this for a long time. But what I love about it is it's really... If you ask it while you're still trying to solve the answer, it'll like give you tips and like try to point you in the right direction without actually giving you the answer. And then I really also love the explain after the fact, because then you can read more about it. So the time complexity for this function is expressed as the sum of the work done in each iteration of the while loop. Inside the while loop, we have a for loop that runs I plus 1 times. Since I starts at n and is halved each time, the total number of operations looks like this. If we ignore the constant plus 1 additions for a moment to look at the growth rate, we see a geometric series. That's correct. In mathematics, the sum of this specific infinite series, where each term is half of the previous, actually approaches 2n. Even if the series is finite, stopping at 1, the sum will always be slightly less than 2n. For example, n equals 100. 100 plus 50 plus 25 plus 12 plus 6 plus 3 plus 1 equals 197. So it's very close to 2n. Since 197 is very close to 2 times 100, we describe this sum as O2n. When we fully reduce this for big O notation, it further simplifies to On because we drop the constant coefficient. However, in the context of this quiz, O2n is the most accurate way to represent that specific summation logic. That was good. That was helpful. I like that extra bit. See, that's that. Anyways, like I said, Boot.Dev is awesome. I will recommend it to everybody forever because I love it. Okay, last one, I think, because then the next one is actually writing some code. Well, we'll see how hard it is, and then we'll decide if I'm going to do it or not. Because it is 5 o'clock, which means I'm going to have to get going. But if we think we can get through the code quickly, maybe I will. Okay. Consider the following function for 2 questions. Have sections returns a list of lists. Wait, didn't I just read this one? Oh. What is... Oh, hilarious. we kind of cheated. What is the most reduced form of this function's complexity? O of n. we asked Boots to help us, and Boots helped us a little too much on that one. All right, let's see how hard this assignment is. We might try and do it fast. Exponential growth sequences. At Locked In, we are interested in simulating the exponential growth of an influencer's followers over a certain period of time, a certain period with an adjustable growth factor. Assignment. Complete the exponential growth function. Given the initial followers count n, growth factor factor, and number of days, return a list containing the exponential growth of followers for each day. Okay. So what are we? We're just return a list containing the exponential growth of followers for each day. So let me just see. See, this is sometimes I do. Oh no, hold on. So initial followers are 10, growth factors 2, days 4. So we are just doing return n times factor. Hold on, this isn't going to work the way I'm saying it is because I need to actually add it to something. So we need to do an empty list. We need the growth equals, it's going to be an empty list. And then for, we'll just do I in days. Then we're going to do grow, it is going to be n, hold on. Can I just do this? Growth.pen n times factor times... Oh no, that's all I really want, right? What will that do? Let's find out. Will that work? No, shit. Oh, for length of days. No, what is days? Hold on. Oh yeah, days is a number. So for I in range days. Oh, I failed all of those. Oh, +1. Days +1. Oh, shoot. I passed some of them. I failed some of the other ones. Why? Growth. So depend n times factor. Oh, duh, because I'm not iterating. Initialize with initial followers. Yes. We need to do... We need to do... What do we need to do? We need... Oh, so we need to do one like this. And then we need to do the factors. Oops. We need to do the initial followers. Initial equals n. And then we need to do initial times... No. What am I doing? Is it initial times I times factor? What am I doing? Oh, that was closer. Wait. Hold on. What am I messing up here? I'm such an idiot. Ah! Oh, wait. I had this right. And then I just blew it. I need to... I need to do the next one. So I have to have I in here somewhere. Because I need to multiply it by I. Right? I've lost my brain. Because I need it to go up every time. But this isn't working. This is going... That's not starting at the right one. Do I start at 0? Initial equals initial followers. Okay. Why am I doing this wrong? What am I doing here? What am I doing here? Like an idiot. I'm just testing some things now. This is where we get wild. Okay. That's giving me the right amount of numbers. But initial days... N initial followers. So in this one, they have 20 followers. So why is that first one not showing up as 20? Because it's doing 0, because you told me that. Fix a variable and keep changing it with each iteration, like 10, then multiply with factor, then it changes to 20. Right. Why can't I remember how to do that properly? Do I need to do... Oh, this is what, like this, right? Is that what you mean? And then change it just after appending. And then we do... initial. Right. So I should do this. I should do something like this, right? Followers. And this equals the actual thing. No, wait. Fuck. Why am I so stupid about this right now? What you're saying totally makes sense, and for some reason I just cannot I cannot for the life of me like focus on what I'm trying to do. And so my brain is just going all over the map. Okay, I need 2 seconds. I need 2 seconds to think about this more carefully because I'm just going silly. Okay, here we go. Here we go. So, let's go through what I'm trying to do. I have a list for growth. I have to go through each day on... I will be the day that I'm on. So I will need to... You're doing it right. I'm getting there. I gotta think through it. I gotta go back through it. I have to. I have to do it. All right. So for I. So I is my current day. So that's a day. That's perfect. So on day 1, we're gonna have the growth. We're just gonna do it as a total equals, and we're on the day 1, and so it's going to be the number of followers, which I haven't defined yet, times the factor. And that will continue to go for each day. So, and then we need to append this total to my growth list. Oops. And then we need to change the followers count to total. Now but I need to initialize followers equals n to start. Damn it. Wait, why am I not doing enough days? Do I need this to start at 0? I'm so close. But I'm not there yet. Because it's timesing it by the factor on day 1. And we can't do that on day 1. So we need to... Wait. Okay, that's the problem. That is the problem. Because on day 1, it's multiplying it by the factor, but we can't have that on day 1. Because on day 1, it should be the initial followers. So we need to do... Yeah. Oh, can you just do range days? But wait, that still won't work, will it? Here, wait, hold on. Ah! Let me go back to this. Okay. Yeah, see, that's not giving me enough days, though. It has to be days plus 1, right? Oh, but okay, I think I figured it out. I think I've got it. Okay, ready? Watch this. Total, no. Followers times, why not just make growth equals n? Well, I don't know. because I don't know what to do. The problem when I look at my answers is that the first day is okay, what if we do this? Hold on. Append n. No. And then append afterwards? But see, okay, wait. So do you see how this is what the first day needs to just be the initial follower. Oh, I see what you're saying. Oh, that's genius. That makes so much sense. And then we just do this, right? Oh, I know I got to put more things back in here, but then we do this, and we can do n, or we'll do followers times factor. Although I guess I can just do n, right? And then do n equals, I'm writing this out twice now, which is silly, but that works, but I probably wrote it in a silly way because I'm doing the same thing twice. But that's genius. Of course you set the first one. That was really, really smart. Nicely done. Of course. I was trying to come up with some convoluted way to force the first thing I add to the list to be not multiplied, but just put it in the list to start. That was really smart. That's the type of thinking that I still struggle with and I am dumb about, because it's like, that was obviously the right answer. That was absolutely the best way to go. Now let's submit it and see if I did this right. Hey, I say I, but I really mean you, obviously. Now I'm interested in what the solution is. You ready to see what they did? Oh, you're so flippin' smart. Nice job. Now, the only thing I didn't do right is, what did they do faster than me? Growth seek. Ah, that's smart. That's smart. That way, I knew there was a way to reduce this of stuff, but that was so smart. Good job. That's a really smart, that's a really clever way to implement it in one line. Because then it's just taking the last... I called it growth. Taking the last item in the index. So in the first one... Because then you don't need this, right? Because then all it's doing is, so it has growth as n, and then the next one is you're taking the last number in the index times the factor and appending it, and that's how you can get the first one. That's really smart. But the growth, the n, was genius. That was, I don't know how long it would have taken me to get there, which, like, part of me is kind of like, hey, Rippy, like, why you give me the answers? But the other part of me is very glad that you did, because I don't know how long it would have taken me to get there. It could have been hours. We could have been here all night. Okay. Now, I officially went way over my time, but this has been a lot of fun. I am really glad that you came in, and I hope you enjoyed it. And hopefully you come back and hang out some more times, because I'm going to... Tomorrow, we're going to do Introduction to Data Structures. So there you go. Should be a good time. Yeah, this was fun. I am going to get out of here, though. I gotta go start getting dinner ready for the old kids. You should get some sleep because it's late. And I hope to... I use the same handle across everything. If you decide to get on X or Twitter, then make sure you add me, and I will definitely make sure to engage with you. And you should put out all your stuff. And don't be nervous about it. Just do it. Seriously. Just get it out there. All right. Thank you again. That was awesome. Thank you very much. I will have a good dinner. You have a good sleep. And we'll see you another time. Okay, I'm out of here. Bye.